Hello class, so this is part 3 of the probability distribution lesson. So in this section, we will be discussing about probability distribution of continuous random variables. So kapag sinabi natin continuous scale, we are dealing with the increments between the whole numbers. So meron tayong mga decimals in short. Okay? The properties of a probability density function for a continuous random variable x, ang ating function of x or the probabilities are greater than or equal to 0. Meaning, we start with 0 and to the positive side ng ating number line. Okay? And it is also defined as the integral of fx dx equal to 1. Andito na naman yung equal to 1 natin. This represents our area in the curve or the probability. So, ang limits natin is negative infinity to positive infinity. This can be represented as our probability. Sabi ko nga kanina, no, yung area na to, yung area under the curve will represent the probability of the event. And there is also what we call the cumulative distribution function, which is defined as f na malaki of x, and then we have the integral of fx dx from negative infinity to x, kung hanggang saan yung limit ng sinasabi nating event. Okay? Kung ano yung pinag-usapan doon. So, remember, sa ating mga tables, yung Poisson, yung distribution, no? Ang mga nakalagay na values doon are the cumulative distribution function. So, yung mga values doon ay laging nag-start sa 0 as we have discussed. If we are looking for the cumulative distribution function f of 3 na malaki, this means that we need to find the probability from the event na 0, na 1, at hanggang 3. So, yan ang ibig sabihin nun. Ito ang mga nakalitaw doon sa ating mga tables. Alright. Sa continuous random variable, ang ating graph is not like yung uniform distribution. So, in this case, we have a normal curve na tinatawag. Okay? So, it's a graph na ang kanyang x-axis dito is an asymptote of the tail, netong left and right. Hindi sila magmi-meet, but they will approach 0. They are asymptotes, parang sa hyperbola, no? Asymptotes. They will approach but they will never meet kahit pa ihaba siya ng ihabang ganun. Okay? So, if you remember your lessons in calculus, we can find the area under the curve, diba? By using the integral function. Okay? So, let's take for example this example, a continuous random variable x that can assume value between x equal to 2 and 5 has a density function given by f of x 2 over 27 times 1 plus x. So, we are asked to find the probability or the area under the curve that tells us yung less than 4. So, halimbawa, kung less than 4 siya, o baka kung ito yung 4, no? Kung i-interpret natin yan, ito yung area na yon. Okay? So, kung area ng 3 less than x less than 4, it could be interpreted as this and this. Kung ito yung 3 and 4, ito lang yung area na hinahanap natin. So, by integration, you can definitely solve that. So, this one is the solution ng ating x less than 4. So, ang ating ginagawa ay yung fx dx natin, no? So, ang function natin is yung 1 plus x. Siyempre, this is a constant. You can remove that sa integration process. And then, we have 2x natin. Okay, and then later we will be going with the UDU na na term for the integration, where u is 1 plus x and the du is 1. So, kapag ganon, meron tayong form ng integral na ganito. Kung babalikan ninyo yung calculus ninyo. And then, we will substitute the limits. The first one, minus nung limit na to, di ba? So, we get this formula. Remember, ang ating probability distribution is either a formula or a table. So, kapag continuous random variables tayo, ang ating answer ay in the form of a formula. Kapag discrete, kagaya yung nung nakaraan, na yung first part, na diniscuss ko ang probability distribution, we have seen a table na nakaprepare for us. So, kapag ating dinidiscuss na yung ating hinahanap, when x is 4, sabi niya, you get this probability. This is the probability or the area under the curve. So, kung i-draw yan, kung ito halimbawa yung 0, ito yung 4, halimbawa, ito yung area na yon. So, meron kang probability ng 16 over 27. So, the same is true with the letter B, fx dx ulit. So, the flow of solution will give us yung ating answer. Okay? So, fortunately, kagaya sa probability sa discrete, pwede natin gawin yung table and then always do that, no? Pag merong problem, or this one, we can use this integration technique and solve every time so that we can have the area under the curve. This one ay 3 and 4, kung ito ang 0, ito yung 3 and 4, ito yung area na yan. Okay? So, fortunately, meron tayong mga tables. Hindi na natin kailangan gawin to isa-isa. Kasi yan ay iisa lang naman ang answer kung ayan ang iyong condition. So, 3 to 4 na kahit ano pang experiment, basta meron kang the same parameters, the same ang answer na nilitaw. Okay? Now, let's move to normal distribution. Yung curve na dinidiscuss ko kanina doon ay ang tinatawag nating normal curve, which is a bell-shaped graph which approximately describes many phenomena that occurs in nature. Okay? Example nun, yung mga quizzes na scores ninyo, yung mga scores ninyo sa quizzes, kapag ginraph natin yon, supposed to be, dapat, ganun ang inyong graph. Okay? So, kung halimbawa, ang mean natin, ang passing ay 50, nandito yung 0 at nandito yung 100, halimbawa, no? Kapag ginraph natin yon, dapat ang inyong scores ay dito kayo. Malapit kayo sa 50. Ito yung bell-shaped graph. Now, kung titignan mabuti, kung minsan, ito yung 50 na passing, dito mataas, tapos dito mababa. Ganyan yung graph, no? Hindi nagiging normal distribution. O kaya naman, kung may nagkaroon halimbawa ng leakage, konti ang nasa 0, mataas yung mga nandun sa 100. So, posibleng ganyan yung maging graph ninyo. What I'm trying to say is, yung normal distribution should be the guide na malalaman natin na yung klase ninyo ay halos lahat ay pumapasa. Kung makikita ninyo dito, dapat walang nakaka-perfect 100, walang nakaka-0. Kasi remember, hindi siya dapat touch kasi asymptotes yung x-axis nito and yung tail ng ating graph. So, mangilan-ilan yung nakakuha ng 90, 60, ganyan, no? So, dito dapat ang pinakamaraming bulk ng estudyante na scores nila. Okay? Ito yung properties natin. Ang mode natin occurs at the center. Symmetric, yung area dito is the same sa area na yan, so that ang total area ng buong curve ay 1. Siyempre, kung symmetric yan, ang area ay 0.5 sa kabila at 0.5 sa kanan. Okay? The point of inflection is at mu plus minus the variance or standard deviation, I mean. Okay? So, inflection, ibig sabihin gaano ba siya nagko-curve? Kasi, yung ating normal curve, makakagawa ka ng normal curve na ganyan yung curve mo. No? Or dito dapat yung center. Ayan. Or meron yung masyadong steep. Ganyan, no? So, imagine this is a symmetrical na lang. So, you can have a very steep tip or just right. Meron ka dapat right height ng ating bell shape. It approaches the horizontal axis asymptotically. So, meaning, they should not touch, no? So, dito sa mga part na yan, actually, if titignan, they approach 0 but they will never touch. The total area under the curve and the horizontal axis is equal to 1. Okay? Now, ang concern natin kanina is, sabi natin, kung tayo ay mag-i-integrate every time, it will take us some time para makuha yung area. No? So, fortunately, meron tayong tinatawag na standard normal distribution. So, yung mga parameters natin ng raw data, pwede natin silang i-transform sa tinatawag nating standard normal variable z. Okay, this one is the translation ng integration natin sa table. Na paano natin babasahin yung table is because of this formula. So, let's have an example para maintindihan natin. So, given the normal distribution, given ang mu na 40 and the standard deviation na 6, we are asked to find the area below 32 ng curve natin. So, it helps na mag-draw kayo ng inyong illustration para ma-visualize ninyo anong area ang hinahanap. Okay? So, ang mu natin is always at the center. So, since 40 yan, no? Yung 32 natin, syempre, nandito siya sa left side. So, ang ating hinahanap ay below 32. So, lahat ng area on this part ay below 32. Okay? Ngayon, kung ito ang mga gagamitin nating values, itong 32, kailangan mong dumaan sa integration. And since sabi natin, meron tayong translation to so that we can read the table, we just use the standard normal variable. So, anong gagawin? Ang x natin is the 32, ang mu natin ay 40, and yung ating standard deviation ay 6. So, we have negative 1.33 ng z. So, ganito yan. Ang p natin ng x is less than 32 is actually equal to the p ng z natin na less than negative 1.33. Kumbaga, yung 32, kinonvert natin siya sa z variable. Okay? Ngayon, kung less than, eto pala, no? So, ngayon, kung less than siya, remember, ang gagamitin nating table is the areas under the normal curve. Ayan siya, areas under the normal curve. So, ang gagawin mo, hahanapin natin yung negative 1.33. So, eto yung negative 1.3. So, yung nawawala ay yung 0.03 pa para maging 1.33 at hahanapin natin yung ating intersection. So, makita natin na yun ay 0.0918. So that, ang ating area na ito ay 9.18%. Okay? So, kung titingnan natin, with ano ang probability na makakuha tayo ng less than 32, makita natin yung area or the probability itself. Okay? So, how to read the table of normal distribution? Sabi ko nga, you need to locate on the left side yung 1.3 and then running across the column dun sa taas, 0.03 para makakuha tayo ng total ng negative 1.33. Okay, this will give us the probability value or the area is specified on the curve. Another example, again, 40 ang mu, 6 ang standard deviation, ang area natin above 27, so ang ating curve above, so these are the curve sa dulo, no? Remember, ang mga table natin, nagre-read sila from f of 0. So, palaging ang reading natin ng table ay from the left side. Okay? Now, ang gagawin, kung i-convert muna natin to sa z, so 27 minus 40 over 6, negative 2.17. Okay, now using the table, we will locate yung negative 2.17. So, negative 2.7, negative 2.1 muna tayo. Tapos, hanapin natin yung sa next decimal, which is 0.07. And yung intersection nila will be yung sagot natin. So, we have 1 minus 0.0150. So, kung i-subtract natin yan, magiging 1 minus 0.015, magiging 0.9850 tayo. Okay? So, makikita nyo naman dito sa ating graph, dito sa ilalim, na yung shaded area ay almost nasakop na niya yung buong graph. So, kasi ang area na to is, ang probability, is 98.50. Diba? So, halos 100% na siya. Okay, so for the cases wherein meron tayong between, halimbawa to, between 42 and 51, so the area that we are looking for is the shaded part. Okay, so remember, ang mga readings ng ating table starts from here, no? From the left. So, ang reading na meron lang tayo is from 0 to 42, yung dito, at yung 0 to 51. Wala tayong reading ng eksakto sa table ng 42 to 51. So, ang gagawin natin mauna is to convert 42 and 51 to the standard normal variable. So, when we do that, we have 0.33 for 42 and 1.83 for 51. The notation would be, kapag between is the 42 less than x less than 51, and then to translate that, para mabasa natin yung table, we need kasi yung less than we subtract yung 51, we subtract yung 42 from the 51. Okay? Bakit nangyari yon? Kasi ang reading natin, mula rito hanggang dito ay 51, at mula dito hanggang dito sa part na to ay 42. So, kung minus natin yung buo hanggang 51, dito, no, i-subtract natin ito, makukuha natin itong part na ito. So, parang sa triangle lang yan, ano? Okay, so, ang gagawin ay, for simplicity, you just have to subtract these two, itong 51 at saka 42, kung ano yung nasa dulo. Okay, so meaning, using the standard z na normal variable natin, 1.83 minus yung reading sa table ng 0.33. If we look at the table, the same, no? This is the positive side ng normal curve, ibig sabihin sa right side. Ibang page ito, no? Kesa dun sa pinapakita ko previously, dun sa mga slides. So, kung 1.83, we locate 1.8. Tapos, sa 3 tayo, 0.03. And the intersection of that will be, asan na? Na 0.9664. Ayun. And then, yung 51 naman, okay, yung 51 ay 42 pala, 0.33. So, 0.3 tayo, and then 0.03. It is equal to 6290, 0.6293. Then, the difference is 0.3371. Okay? Let's have another example. So, the diameter of the steel bearing is normally distributed with a mean of 10 centimeters and a standard deviation of 0.03 centimeters. So, what proportion of bearings will have diameters exceeding 10.075? The next one is, what is the probability that a bearing will have a diameter between 9.97 and 10.03 centimeters? And the last one is, below what diameter size will 15% of the bearings fall? So, for letter A, since ang ating hinahanap ay exceeding 10.075, ang notation natin will be greater than. So, kapag greater than siya, the first thing to do is convert muna pala, no, yung z variable natin. So, we get yung 2.5. And whenever we have the sign greater than, we need to change it, no, sa ating less than value, so we will be able to read yung table natin. Kasi kung greater than yan, wala tayong mariread sa table. Okay? So, what you do for simplicity is just convert it 1 minus nung less than, no, ng ating converted z variable. So, looking at the table, again, positive yung tinitignan nating side. So, 2.5 and then 0, 0. Kasi sakto siya. So, we have 0.9338. Yun, ano? So, 1 minus 0.9938. So, ang ating value will be maliit na maliit, no? 0.062%. Tama ba? No? So, maliit lang yung percentage na magkakaroon ng diameters exceeding yung 10. Ang mean ay 10. So, kung titignan mo, maganda, no? Kasi, ibig sabihin, yung 10.075 na bearing na yon ay napakaliit ng tsansa na mangyayari siya. Okay? Moving on with the letter B. So, we will have a diameter between 9.97 and 10.03. Ganon, ulit, kagaya nung example natin sa example 3, no? Convert yung z ng 9.97 and 10.03. So, we get negative 1 at positive 1. So, dito sa ating table, yung positive, unahin natin yung positive 1 at ito. So, 8.143. Dito naman sa negative 1.0, ayan, dito siya. So, 0.1587. So, subtract yon, we get the area between. Okay, so, kung i-draw ninyo yan, it helps to visualize the problem. Ang mean natin lagi sa gitna, 10. So, kung 9.97, dito siya sa less than ng 10, and then yung 10.075, ayan. Yan yung area na yun, 68.26%. Then, the last one is a different question, no? The diameter of the steel bearing with the mean 10 centimeters and a standard deviation of 0.03, tinatanong sa atin, what diameter size will 15% of the bearings fall? Yung diameter, anong diameter ng mga bearing na yon, no, na nagko-comprise ng 15% ng kabuuan. Okay? Ang given ngayon natin is the probability, which is 0.15. And then, dun sa ating table, okay, the last one, iba yung way ng solution niya, no? Kasi ang tinatanong sa atin, yung mismong diameter. So, ang given actually na 15% is the area or the probability na magkakaroon ng ganong diameter size. Okay? So, ang gagawin ninyo is to look at the table at iisa-isahin na titignan alin dyan ang eksaktong 0.15 or malapit sa 0.15. So, ito mga to 0, kasi sunod-sunod naman yan eh. So, if we are going to look, dito tayo banda, ito na yung mga 0.15 natin. Ayan. No? So, ang pinakamalapit ay itong dalawa. No? So, ngayon, alin dyan ang ating kukunin? So, ang gagawin ninyo is, titignan ninyo alin sa dalawa ang mas konti ang difference sa 0.15. So, you have to subtract 0.1515 ng 0.15. So, that will be 0.0015. Okay? Yung isa naman, 0.15 naman siya minus nung nitong second reading na 0.1492, which gives us, tingnan natin, 0.0008. Okay, 0.0008. Tatlong 0. Ito, dalawa lang. So, meaning, mas malapit ang 0.15 dito sa value na ito. Okay? If that is the case, then you will read saan tumatama yung z na yon. Negative 1.1 plus yung katapat niyang decimal. So, kumbaga, baliktad yung pagbasa natin. Sa loob naman tayo nagbabasa. So, magkakaroon tayo ng 1.04 which gives us yung value na ito. So, I just want to clarify dun sa pag-read ng table kapag nag-estimate tayo kung ano yung pinakamalapit sa 0.15, no? Actually, you can solve for the exact value by using interpolation. No? So, ito, pag gusto natin yung exact value, dun sa ating, klase, gagamitin natin yung kaninang diniscuss ko. But, I just want you to understand paano yung exact value. So, ang ating dalawang pinakamalapit sa 0.15 ay ito. So, let us, ito yung z na yun, ano? Yung z na yun ay 1 negative 1.0. Tapos, sa taas, ito yung mga decimal points na katapat nitong dalawa. So, 0.03 at saka 0.04. Dito, yung value ng 0.1515 at yung value ng 1492. So, sa pagitan nila is yung exact na 0.15. So, hindi natin alam yung decimal point dito. By using interpolation, when we subtract this, may arrow, no? magiging x minus 0.04. And then this one, kung saan kayo nagumpisa at nag-end, same din yung direction. So, magiging 0.03 minus 0.04 is equal to, dito ulit tayo. Susundan nyo kung ano yung nauna. So, dito siya, no? 0.15 minus 0.1492, and the other one will be like this, 0.1515 minus 0.1492. Okay? Tapos, isolve natin yung x. Doon sa computation ko kanina, meron tayong 0.0365. Tapos, marami pang decimals dyan. So, doon sa ating z kasi, doon sa example, ang ginamit natin ay negative 1.04. By estimation yan, ano? Pero kung tutusin, ang talagang value niya ay yung nakuha natin na decimal na to, 365. No, of course, kung i-round off siya, mas malapit siya doon. Okay? Moving on with the solution, since alam na natin yung standard z value, we use this formula now, no? Yung pag naghahanap tayo ng pinipinpoint natin yung diameter size mismo or kung ano yung variable na yon, ano? We use the mu plus 2 times the standard deviation. So, all you have to do is substitute. Okay? So, ayan ang ating lilitaw na sagot. O, tanong natin, no, saan ba nanggaling ito? Nanggaling ito dun sa ginagamit natin na x minus mu divided by the standard deviation. So, ang ginawa lang is sinubstitute ito, and this one. So, you get the exact value. Okay? So, we have 9.969 centimeters ito, no? So, therefore, 15% of bearings will have a diameter below the 9.969 centimeters. So, that's it for the continuous random variable or the continuous probability distribution. So, that ends our discussion ng buong probability distribution. And wait for my announcements ng mga seatwork na isasubmit. Thank you!